Good day to all of you. So in this video, we, Judy Macy Magpulong and Nor-hannifah S. Magandia, will be discussing about mass wasting. Before we formally introduce what mass wasting is, let us know the objectives of this discussion. It is to explain and discuss what mass wasting is, identify its causes, knowing its effects, evaluate its classification, identify its type, and to evaluate how to prevent mass wasting. Mass wasting refers to the downslope movement of rock, regolith, and soil because of gravity. It is a natural process that occurs after weathering. The term landslide is often used as a synonym for mass wasting. Mass wasting is also known as mass movement. To simply put, gravity pulls loose rock and soil downhill. Mass wasting is the process of erosion whereby rock, soil, and other earth materials move down the slope because of gravitational forces. Mass wasting occurs when a slope fails. A slope fails when it is too steep and unstable for existing materials and conditions. That is why changes in slope affects mass wasting. Slope stability is ultimately determined by two principal factors: the slope angle and the strength of the underlying material. Force of gravity, which plays a part in mass wasting, is constant on the Earth's surface for the most part, although small variations exist depending on the elevation and density of the underlying rock. A variety of conditions affect the development of mass wasting in a particular area, and these are the gravity, angle of response, water, time, type of material, climate, and vegetation. The first one is gravity. It is a combination of the normal force and the shear force causes gravity to act on an item. The normal force is perpendicular to the slope the object rests on, and the shear force is parallel to the surface of the slope. Steep slopes have higher shear forces. The steeper the slope, the greater the chance an object will slide. Take note that the shear strength is an object's resistance to movement that needs to be overcome in order to make it move. Shear strength is proportional to how solid the mass is, the density of plant roots, the amount of water present, and the roughness of the particles in the mass. Angle of response. The angle of response is the steepest angle at which loose material will remain in place. It is largely dependent on the size, shape, and roughness of the particles. The angle varies from about 25 degrees to about 40 degrees. Water. Water increases the weight of a mass of Earth's material. It reduces the shear strength by forcing sediment particles apart through pore pressure, which reduces the friction between the particles. Alternatively, smaller amounts of water that don't completely fill the pores are distributed as thin films around the sediment particles, which are attracted to each other through surface tension, increasing the cohesiveness of the mass. Thus, saturated materials are much more likely to flow than a mass that is only a little wet. Time. Physical and chemical weathering can weaken slope materials, decreasing resisting force. This causes the rocks to become very weak, and mass wasting occurs. Type of material. Weak rocks, like sedimentary rocks, will weather quickly than hard rocks, the igneous and the metamorphic rocks. Climate. Climate plays a vital role in weathering of material since it influences the amount and timing of water in the form of rain and snow. And last but not the least, the vegetation. Plant roots provide a strong interlocking network to hold unconsolidated rocks and sediment. Vegetation removes moisture from the soil. Next are the factors responsible for mass wasting: slope modification, heavy rainfall, oversteeping of the slope, and the rapid snowmelt. Slope modification, removal of vegetation, plants and trees removed, water from the soil. Building of structures, decrease in cohesive force or increase downslope force. Force due to added weight will cause movement. Heavy rainfall, addition of water in soil, lubricates the material, adds weight, and increases pore pressure. Ground vibrations. Earthquakes is an example of ground vibrations. It triggers the rock and initiates its movement. Another example is human-induced, blasting for construction, large equipment, and etc. Oversteeping of the slope, construction of roads, buildings, homes, and etc. Waves cutting cliffs on a shoreline can be human-induced or by natural
processes increases the downslope force. Classification of mass wasting. Four kinds of movements are generally recognized as flow, slide, fall, and slump. Fall. A fall is defined as earth material that falls freely from a cliff or steep face. Slide. If the mass moves as a solid unit along a surface or plane, it is called a slip. So a slip that moves along a surface parallel to the slope is called a slide. Flow. A mass wasting event is called a flow if the mass moves downslope like a viscous fluid. Slump. So a slump is the result of a downward movement of the upper part of the mass, leaving a steep scarp or a cliff, and pushing outward of the lower section of the mass along a more horizontal plane. Types of mass wasting. So there are 7 types of mass wasting. First, slump. Second, rock falls and rock slides. Third, mud flow. Fourth, earth flow. Fifth, creep. Sixth, solifluction. And the last but not the least, debris flow. Slump. Earth material that has moved as a unit along a curved surface is called slump. A slumped mass of sediment is typically clay-rich. Slump usually results when the geometrical stability of a slope is compromised by the undercutting of its base, such as by wave action, a meandering river, or construction. Rockfalls. Rockfalls happen when chunks of rock slip away from a cliff or steep rock face. This develop from river or wave activity undercutting the rock face. Large breaks may eventually get loosened as a result of frost wedging, falling. So the accumulation of rock debris at the base of a steep slope is called talus. Rock slides. Rock slides usually follow a zone of weakness, such as a bedding plane or foliation plane. Separation of the rock is more likely along these planes because of their reduced shear strength. Water also tends to be channeled along these planes, which increases slippage. Collisions down the slope generally break the rock mass into rubble that eventually comes to rest. If steep slopes are involved, a fast-moving rock avalanche may result. The rock or rock avalanche loses energy and speed as it moves across more level terrain. Mud flow. A mud flow is a liquidly mass of soil, rock debris, and water that moves quickly down a well-defined channel. Generally viscous and muddy-colored, it can be powerful enough to move large automobiles and buildings. So heavy rainfall that saturates the loose soil and sediment causes mud flows, which are most common in mountainous semi-arid areas with little vegetation. A mud flow is two types: lahar and debris flow. Lahar. They occur either during an eruption or when a volcanic is quiet. They cause mass destruction of land and life. Debris flow. It is a mixture of rocks, debris, or soil and water. It moves as viscous fluid. Debris flow is common after heavy rain. Earth flow. It is called an earth flow when the earth material moves down a hillside as a fluid-like mass. This flows typically occurs in humid areas on steep slopes with thick, clay-rich soil that becomes saturated with water during storms. The earth flow usually leaves a steep scarp behind where it separated from the hillside. Earth flow typically have rounded, hilly fronts. A common trigger for an earth flow is the undercutting of the slope by erosion from wave action or rivers or by construction projects. Creep. It is called creep when a slow, gradual movement of soil or regolith downhill over time. The normal velocity is less than 1 centimeter per year. Soil particles are gradually moved down the slope by freezing and thawing, which helps to prevent soil creep. Utility poles that are tilted and are moving out of alignment year after year are examples of creep at the surface. So, vegetation helps reduce the rate of soil creep. Solifluction. A variety of earth flow called solifluction is the flow of water-saturated earth material over an impermeable surface such as permafrost. It occurs frequently in bitterly cold regions such as in Alaska or Canada. Springtime temperature thaw only the first few feet of the frozen ground, which is the active layer, which becomes saturated quickly and slowly flows over the ever-frozen permafrost below. So the solifluction can occur on even the gentlest of slopes. Springtime temperature thaw only the first few feet of the frozen ground, which is the active layer, which becomes saturated quickly and slowly. The soil finally settles on level. Debris flow. The deadliest variety of debris flow is the debris avalanche. It is a rapidly turning mass of rock debris, soil, water, and earth that race down very steep slopes. It has been theorized that trapped air may increase the speed of an avalanche by acting as a cushion between the debris and the underlying surface. Prevention of mass wasting. We cannot prevent mass wasting, but we can delay it through efforts to strengthen the materials and slopes. Strategies including there are also efforts that we can do to delay mass wasting. It is to move materials or houses from the top to the two. Build barriers. Build retaining walls. Drain slope. Plant vegetation. Prevent flooding.